Welcome to Dr. Dan Science. Today we're going to have ourselves a diffusing type of experiment. We're going to look at this process known as diffusion that we not only see in physical science, we also see it in biology and chemistry and all kinds of things, and we see it all around. First of all, we should talk about what is a physical change. A physical change is something where you can have molecules that they can change their form, but you really don't change the anatomy of the atom or the molecule itself. Everything stays the same. And when we think of diffusion, diffusion really is an example of a physical change. Anytime you will dissolve one thing into another, you're really retaining the individual properties and the identity of those substances. For example, what we're going to try to do today is we're going to take some sugar. This sugar, which I have right here, is going to be put into a little napkin, could be a paper towel, doesn't matter, and we're going to pour it right into the center of it, make a nice little mound. And then we're going to wrap this whole thing up and wrap tape around the top of it so we have this nice little unit right here. We take this napkin with its contents and put it into this bowl of water. Now I want you to think a little bit about what's going on here. We can pretend that this napkin represents the outside portion of a cell. So we could say that the napkin is the cell membrane. The contents which are inside of it are going to be like the cytoplasm or whatever else you'd have inside of that with all the organelles if we're looking at a eukaryotic cell. But when we put this thing in there, what's going to happen in terms of the material inside relative to the stuff outside? Well, we're putting it into water. Pure water, it's a compound, it's going to have just water molecules. And one thing we see about diffusion, which is a passive type of an activity, it doesn't take any energy for things to move across a membrane. We're going to have this highly concentrated bundle of sugar, and it's going to start moving through the pores of the paper towel. Or we could say the contents of the cell is moving through the cell membrane. So we're going to go ahead and we're going to be setting this thing in there in a short period of time, and I want you to think about what's going to happen. If we think of diffusion as going from a high solute concentration, the solute is the thing that gets dissolved. The solvent would be the water, and we make a solution which would be sugar water. But when we think of diffusion, diffusion is going from a high solute concentration, which is this bundle of sugar, to a low solute concentration, which is the water. And we're going to see that this is going to move from high concentration to low concentration. Even though there's no sugar in there right now, and I could test that. I could take a teaspoon and simply taste it. It would taste just like regular water. Tasteless, colorless, odorless. But after we put this in there over a period of time, let's say 2 hours, and actually we'll speed it up, you'll get a chance to see some evidence of diffusion before your eyes. It's a passive process, requires no energy. In fact, it doesn't even require a membrane. One other example that we could think of for diffusion would be having a perfume bottle, a real stinky perfume bottle. All this stuff is concentrated within the bottle itself. As soon as you open the cap, then that perfume, the molecules are going to leave it and begin to start filling up the room that the perfume bottle's in. Another example of that would be food coloring. You put a little drop of food coloring, that's the concentrated stuff, it spreads out evenly into the various areas. So with that said, let's go do it. We're going to let it just drop inside. And you can kind of watch this and see if we see any evidence here that diffusion is taking place. We'll see you in a little bit. Patience is a virtue. We got through this lab and we can actually see some really cool stuff took place. We went ahead and we put that sugar into that napkin. And what I didn't tell you is I did add just a little something else in there. We had a little gelatin capsule and I ended up putting some food coloring in. It was really cool. Did you notice where all of a sudden this napkin lifted on its own, got lighter, and then you just start seeing all this sugar pouring out and then dye started coming out? Too much fun. Beautiful example of what we're talking about, a physical change. We're dissolving one thing into another. We could talk about that the liquid, the water is the solvent. We'd say that the solute, the sugar, and then the mixture that we have there is the solution. How awesome is that? Well, with all that said, we're going to probably wrap this thing up. We do have that other process that we should consider, and that's osmosis. Osmosis is also a physical change, but now instead of having both the solvent and the solute potentially moving around, now when we have osmosis, it's always going to be just the solvent moves, just the water moves. And it's going to go from a low solute concentration to a high solute concentration. And it's in that situation that we do have a semi-permeable membrane. The water can move back and forth freely, but the solutes cannot. So make sure you understand the difference between osmosis versus what we have right here. And we'll just finish off with just maybe adding one more little thing. I just add a couple more things. Oh my goodness, something crazy is happening. What are we looking at here? I've got this highly concentrated stuff known as dry ice. Dry ice, if you don't know, is carbon dioxide, and it's in the solid form. This stuff is super cold. They say like a minus 75 degrees Celsius. You don't want to touch this stuff because what's going to happen to you? You're going to end up getting frostbite. You can get burned from it, a cold burn. And we go from this high concentration of CO2, and notice what's happening. It's coming out of this and it's dispersing all over the place. So here's a beautiful example of a gas doing it. We just saw liquids doing this. And now the solid, if you haven't ever heard of this before, but it's called dry ice because there's really no liquid phase to it. It goes directly from the solid form into the gas form. It's called sublimation. Thank you again for watching. Dr. Dan Science.